Okay, I think you're probably ready for something a little bit different, so you knew it was coming. Here's a trig example. Same thing that we've been doing. We're going to find the second derivative, and of course we have an implicit function. I think this one is probably impossible to solve for y, if not extremely ugly. So we are going to take the derivative of both sides with respect to x and see what we end up with. So let's see, on the left-hand side, I'm going to have derivative of y is 1, but that's with respect to y, so I'm going to have to follow that times dy dx. So I have derivative with respect to x, and then I'm going to have plus derivative of sine is cosine y, and again, now I've got to do derivative of y with respect to x, dy dx. Equal to, on the right hand side, derivative of x is just a good old 1. So this time, finally have something a little bit more interesting to deal with, and we saw some examples in our first lesson on implicit differentiation where we did end up with two terms that had a dy dx, and then we had to follow the process of factoring out the dy dx. First put them on the same side, but in this case they're on the same side, and now factor out a dy dx so that we can solve for dy dx. So I'm going to go ahead and factor that out, and I'm going to be left with 1 plus cosine y. So if you distribute that back through, you'd end up with the line above it equals 1, and then I'm of course going to divide on both sides. So I get dy dx is equal to 1 over 1 plus cosine y. And I'm going to look at that and see if I can simplify it. I don't think there's anything I can do with that. So that is my first derivative. Moving on. So let's go ahead and take the derivative of our derivative, which means that I'm going to be looking at derivative with respect to x of dy dx, and then of course derivative with respect to x of 1 over 1 plus cosine y. So on the left hand side, I'm going to get my second derivative, and on the right hand side, surprise surprise, we have another quotient rule. Seems to be a popular thing. So we are going to have to deal with our quotient rule, and you know what, I'm just going to keep that one up there because I know I'm going to need that in a second, and let's go ahead and move this over so I've got a little bit of room to work. So quotient rule, I'm going to have denominator 1 plus cosine y. Now would be a good time to kind of pause the video and see if you guys can do this one on your own. Denominator times derivative of the numerator, and it'd be possible to do this one without the quotient rule. You could put the denominator and the numerator as a power to the negative 1 if you wanted to. This one just seems easier to me to go ahead and use the quotient rule. So times my numerator times my derivative of my denominator. Which I think I'm just squeezing in there, over denominator squared. So let's go ahead and actually take the derivative. Derivative of 1 with respect to x is 0. So I'm going to have 1 plus cosine y times 0, which is ultimately going to go away. Not to jump ahead of myself, but I do know that's going to happen. Minus 1 times derivative of my denominator was 1. Looks like I lost a 1 there. 1 plus cosine y, derivative of 1 is 0. Derivative of cosine is negative sine of y. And I'm going to have to follow that one times dy dx since I am doing my implicit differentiation. So let's throw the denominator back in there, cosine y, quantity squared. And if I can move this, so we've got this part here is gone because that's all 0. If I simplify what I have after that, it looks like I've got negative 1 times negative sine y, so that's going to be a positive sine y, times my dy dx, and I'm going to go ahead and make my substitution for dy dx of 1 over 1 plus cosine y. And then I've got my denominator of 1 plus cosine y squared. And this time I don't have two terms in the numerator, so a little bit simpler in terms of the algebra here, because I've really just got a numerator and denominator. Better to look at that as sine y over 1 plus cosine y. And then that's all over my 1 plus cosine y quantity squared. And if I want to get rid of my denominator, I'm going to multiply by 1 over 1 plus cosine y quantity squared to get my denominator cancel out, and I've got to do the same thing in the numerator, 1 over 1 plus cosine y quantity squared. And now I'm looking at final answer of sine y over 1 plus cosine y times 1 plus cosine y quantity squared gives me 1 plus cosine y quantity cubed in the denominator, and that was my second derivative right there. So we've got first derivative, second derivative. Definitely can see some similarities in what we end up with. That 1 plus cosine y is a common factor there.